This is part 3 in a series of videos in which I am attempting to repair this. It's a dumb terminal. Specifically it's an ADM-3A. Very popular at the time. This was designed and released in the very early to mid 1970s, so very old piece of technology, very advanced for the time. It was popular because it was very compact, and the way they made it so compact was to cram a large number of ICs onto the main board. So it's quite simple in its overall layout. We've got a big transformer underneath this board. The board itself, the keyboard's integral to the main board, and then we just have a CRT monitor in the top part of the case. So in the first 2 videos in this series I got as far as dealing with the cataracts on the CRT and testing the CRT display itself, and that's working fine. Piece of advice I'm going to give now, if you ignore all the other advice I give you, this is advice I strongly recommend you at least think about. If you're going to repair something complex like this, is get yourself comfortable on the bench. Now you can see at the moment what we have is the monitor's pointing the wrong way, so I can't see the screen. It's important that I can see the screen to work on something like this, and I've got a few options here. I can either put a mirror behind the monitor. I can keep leaning around the monitor every time I try to do something or probe something. Very inconvenient, very cumbersome, and almost certainly will slow down and make the repair much more difficult. So as I say, before you start something like this, get yourself comfortable. So what I'm going to do is attach the monitor through an adapter that I've made, and literally something like this will take you probably 5 or 10 minutes to knock up, and especially once you've done it a few times, you've got the bits knocking around, then it literally is just minutes to do something like this. And what I can now do is uncouple the top part of the case from the bottom half, rest the monitor alongside the board so I can see it properly, and then I can start fault finding proper on the main board. And this doesn't look like much, but it will save an awful lot of aggravation when dealing with something complex like this. So I'll just get it laid out and organised as I am comfortable working with it on the bench, and then we can start the interesting part of this series and look at fault finding on the main PCB. So unusually for me, I actually have a set of schematics for this, so it should make life very much easier. And the way I'm going to approach this initially is, I know the owner's turned this on already, but even so I wanted to check the various rails first. So I've already gone through with the multimeter. I've checked for shorts and leakage on the various rails, and I've tested the larger caps for leakage and capacity. They seem fine, and I can't find anything wrong with the board in terms of shorts on the supply. The resistance across the supplies seems fine, and what I want to do now is power it up and do some initial testing of the power supplies. So it's a very straightforward supply. We just have 3 7805s providing 3 5-volt rails. They're referred to as plus 5 volts A, B and C, and then we have a plus 12 volt, minus 12 volts, and then a 15 volt for the monitor. So I'll go through and test all these. These 3 are the 3 at the back. The large 15 volt regulator is, I believe, this one. The plus and minus 12 volt regulators are in the corner here, and the large power device for this is on this heatsink. So what I can do is just go through these. I'll test them, make sure that all these supplies are fine, and then what I can do is start seeing what the machine's actually doing, how far it's running, and then we can start trying to figure out what faults it might have. So I'll start by powering it up. I'll start measuring some of the voltages. So we've got 5 volts there, 5 volts there, 5 volts there. So A, B and C are fine. Notice there's something on the monitor. Just supply for the monitor's fine. Okay, so looking at the screen, what this tells us already is that the memory seems to have initialized to all values of 0, or there's something wrong with the scanning circuitry and it's always showing the same character. But it does show that the counters for the display, that's both line and character, are working, so there is at least quite a reasonable amount of activity on the board. It doesn't respond to key presses. Brightness control works. I'll turn that down so we don't do any harm to the screen. And so I'll go through and test the rest of the supplies, and if I don't find any issues with those, then we'll start trying to form a plan of action here as to how we're going to go about fault finding on this. Okay, I've got the scope set up, and as you can see, what we have at the moment on the screen is a whole screen full of 0 values. Now what I've done so far is I've popped out the character generator ROMs. There are 2 character generator ROMs on this machine, one for lowercase characters and one for uppercase characters, and I'm not quite sure which of those 2 the 0 character was in, so I popped out the one that's in a socket, and we've still got the zeros appearing on the screen. So it does appear that the uppercase character ROM and the one that contains the digits is the one that's soldered to the board, and that does appear to be working because we are getting the 0 characters reliably being displayed on the screen, but nothing happens when I press any keys. I haven't looked at the serial comms yet. I want to do a bit of investigative work before I start doing anything else. So the next thing to do is to put it into what amounts to a second character set mode, and we should then be able to boot up to a clear screen with just the cursor. So we'll switch it into the main character set, reboot the machine, and sure enough we're getting just the cursor on the screen. Let's move the camera across so you can see that. I'll turn the brightness up, not quite sure how clearly that's coming out. So we're getting a cursor on the screen. Now the other thing I should be able to do is to select a different form of cursor. What I'm trying to do here is to see how much of this board is running, and this is effectively layered logic, so various things happen in certain orders and then various signals are fed through the different layers of the logic, and what comes out at the end is what's displayed on the screen and what's sent out through the serial ports. So we have these 2 banks of DIL switches up here next to the serial connectors, so it looks like on the face of it they are for configuring the serial comms, but they're not. They're for setting system options. A bit of odd placement, but that's what they're for. And the one I'm interested in here is the top one on the right hand bank, and that's the cursor control switch. What that does is it sets the form of the cursor and also the position of the cursor. There's 2 general ways this screen can operate. It can either have text scrolling down the screen, or it can input text at the bottom of the screen and then the text will scroll up above the cursor line, and that's what this switch controls. And because this level of the logic is fairly low down in the logic chain, then what I want to do is to see if we have any control using that switch on what's being displayed on the screen, because that will eliminate about 80% of the electronics if we can control the cursor. So I'm just going to flip this switch over and see if it allows us to control the cursor. Okay, so I've flipped over the cursor switch, so we can now see the cursor is at the bottom of the screen, and it is the short cursor rather than the block cursor. So in other words, the cursor control does seem to be doing what it's supposed to, meaning that a lot of the board is actually running. What I'm going to do now is reboot the machine and see if we get the block fill back, and I'm going to switch the machine back to the alternate character set. So especially I'm going to put it into what I'm going to use as a test mode. So I'll flip the switch back and then I'll try rebooting the machine, and sure enough we have a full screen of zeros with the cursor at the bottom. The other thing I want to try now is to test the memory. Now there's a fairly easy shortcut route for testing memory on this machine. It's kind of an oddball way of doing it, but it does tend to work. It's always worked in the past. And that is, there's a switch on the left-hand bank at the bottom, and it's labelled 12 lines, 24 lines. So this machine can run in one of two modes. You can either have 12 lines with a big space between each line, so it'll still fill the screen, but it'll be kind of a double-spaced line. Or it can run in its current mode, which is 24 line. But if we switch it to 12 line and then reboot it, only every other line will effectively be initialized, and the blank lines in memory won't be initialized. If we then switch back to 24 line, we should see garbage in every other line on the display if the memory is working, because what that will indicate is that if we're seeing different characters in every position in the lines that weren't initialized, we know that the system is able to pass the correct positional character information through to the memory system, and then when the memory is scanning RAM, it's correctly interpreting those values. If it just remains with them all at 0, we know that this problem is further down the logic chain, and that this could just be a result of it's just defaulting to 0 because it can't read the RAM. So in other words, it's going to let us test to see if the RAM is able to hold the actual character values. So what I'm going to do is flip the monitor to 12 characters. You can see it's turned off every other line. Because every other line is now switched off, and this control is quite low down in the logic chain, then if we reboot the machine, the lines that are currently not being displayed will not be initialized. That is, their memory locations will not be initialized to what I think must just be 0. So I'll reboot the machine. We'll get back exactly what we have in theory, but if I then switch back to 24 line mode, we should get garbage on every other line. So I'll reboot the machine, and so we're now getting what we expected. That's a 0 on every line that's displayed. But if I now go back to 24 line, we should get garbage on each alternate line, and indeed we're getting garbage on every other line. So what this is telling me is that the memory is actually working, and the screen scanning of that memory is working, because each character is different. So if it wasn't working and it was always by default selecting the same character, we'd just still get 0s. But because we're now getting garbage, what the machine's doing is reliably showing us the value stored, or at least the character value stored in each memory location. I'll just try rebooting the machine again to make sure these are initialized back to 0. And indeed they are. So that tells us quite a lot. We know now that at least probably 90% of the board is working. So we know the RAM is working, we know the character ROMs are okay, we know that the scanning circuits for the display work fine, but when we press a key, nothing happens. We don't get any characters. So that tends to indicate that the keyboard is not being scanned. I don't know if there's anything coming in and out of the port yet. I'll look at that later. But for now, what I want to do is look at the keyboard electronics and find out why the keys are not having any effect. Okay, so I've been looking at the schematic for the keyboard. So we've got the keyboard here, and then we've got the multiplexers that are responsible for scanning the keyboard. But there is no keyboard clock, so there's nothing coming into this pin. And it's quite a nice layout on this board. There's a grid arrangement, so every single device where it says, for example, L7 is row 7, column L, so very easy to find the components on this. But there's nothing on pin 10 of this particular device, so I'll have a dig around and see if I can find anything. But what's happening is when I press a key, we're never getting a strobe out of the key data line to indicate that data is being accepted or read from the keys. So I'll have a look around, see if I can find something, and get back on camera if I can try and figure out what's going on. So I've been investigating the circuitry around the keyboard control, and the keys were being scanned, so I could see the signal levels changing at the input to the multiplexer that detects the key presses, and the lines were being strobed. but nothing was getting through here. So effectively there was an issue on this device, and it's not the device itself, there was just a dry joint on pin 8. So I've resoldered that. That's this device. And now if I look at key 5, which is the output, this is the data detect output, so it's this line here, and it should go low every time a key press is detected. So I've got the scope on that line. You see it's high at the moment. If I press the key and hold the key, it's going low. So that is now functional. It does work on all the keys, so that's what we'd expect to see. And moreover, if I move the camera back across to the monitor and press some more keys, you can see that we are now getting keys or key presses characters appearing on the screen. Shift works, and I've tried all the characters, and every key on the keyboard works. And if I hold in the repeat and press a key, you can see that's working. Line feed is working, carriage return. So basically the entire keyboard is now working, just a simple dry joint, and that's now working as it should do. The next thing I want to do is look at the serial comms and see if we're getting anything at the output for the serial ports. So I'll just grab the schematic and the information for that, and then we'll have a look to see if we're getting any communications information. So looking back at the board, what I want to do is to start by seeing if the asynchronous transmitter receiver is actually getting a clock. So that's this big LSI chip here. So pin 17 should be the receive clock, and as we can see we're getting a signal there, 155 kilohertz, and it's set to 9600, so that's correct. I'll try a few different baud rates, so I'll try the next one down, which should be half of that. So I'll just switch it over to an alternate rate, and indeed we're getting half that, and then we'll try one more, we should be getting half that again, and indeed we are. So that's working fine. I'll set it back to 9600. So the baud rate generator is working fine. Next thing I want to do is to see if we're getting anything out of the actual communications port. And what should happen, the way I've got this machine configured, is anytime I press a key, the character should be sent transparently straight out of the comms port. So I'll try monitoring the output pin. Before I do that, this will be plus or minus 12 volt signal, so I'll just adjust the scope, and also we'll slow it down because it's obviously going to be a much slower signal. And then we'll try looking at the signal and see if we're actually getting anything. Just need to adjust the position on the scope. There we go. I'll press the key, and indeed we are getting some serial data. So I'll press a few keys. You should see a different code for each one I press. That's an S, a D, an F. As you can see, we are reliably getting good serial data. So what I'll do now is hook this up to the lab PC, and we'll see if we can get it to communicate with the terminal. Okay, I've got the terminal hooked up to the lab PC. I've configured it so that it should communicate, and what I'll do now is just send it a simple text file and see if the terminal can display it. Okay, as we can see, the terminal can display incoming data. I can press keys on the terminal, and that works just fine. And this data is also appearing on the screen of the lab PC, so it's working in both directions. I have found a few minor faults with it, mostly relating to the actual switches. Found a couple of poor connections. I found when I was pressing the board, the system would sometimes just stop working, so that was just a few poor connections. As you can see, I've given the board a really good clean, and I did that several days ago, and I've allowed it to dry, but it is very clean. The keyboard's come up nice and clean. I'll keep going through this, do a few more checks to make sure it's working reliably, and then I'll reassemble it, and in the next video we'll have a bit of fun and see what it can do.